Bismillahirrahmanirrahim. Assalamu alaikum. In this lecture, we'll begin the discussion about yet another category of power electronic converters, that is DC to AC type converters. These are commonly known as inverters. Okay, in which the input is of DC type, okay, and the output is of AC type. Okay, within the AC, then there are like a few possibilities that either we can have sinusoidal output, okay, in the form of alternating current or voltage, or we can have a square wave as an output. But commonly for most of the applications, we require that the voltage provided to them should be of sinusoidal type. So that is why these are the inverter circuits which are of most interest to us and everyone else, and that is why these are the ones which are quite often discussed and investigated. Okay, and our interest will also and our discussion will also mostly focus on the type of inverters in which the output voltage waveforms are of sinusoidal type. Okay, the inverters are quite often used in some AC motor drives and various you can say uninterruptible power supply applications. Okay, the objective primarily in all of these applications is to have an output voltage whose magnitude as well as frequency can be controlled. So talking about the applications, we quite often have them in AC motor drives. Okay, these are the common applications of inverter circuits. We'll also see one block diagram shortly, okay, in which we'll have some input AC voltage from the utility or the grid, and that will be first converted to a DC voltage through a controlled or uncontrolled rectifier, mostly uncontrolled rectifier, and then through the inverter circuit it will be converted to AC voltage again. So why is this first conversion and then inversion required? Because as I mentioned that the objective in this particular case is we should be able to control the magnitude and frequency of the sinusoidal output voltage. So in AC motor drive applications, what do we have? That we have some like input coming from the utility or grid, which often has a frequency of 50 or 60 hertz. Okay, then we have certain type of like if it is an uncontrolled rectifier circuit, so it will convert this AC into DC voltage. Okay, then we'll have some certain, you can say DC link capacitor, commonly this is called, and then the output will be inverted into AC with the help of some certain, you can say, mechanism which will be of DC to AC type, and then in the output we'll have some load in the form of AC motor. So we can see that if we had supplied this particular voltage directly to this AC motor drive, so we could not have had that controlled functionality available to us. We could not have controlled the magnitude of this input voltage. Okay, it would have complete dependence on the value that is being provided by the grid, and in the same way we could not have had the flexibility or the option available to control this frequency. Once we have established this intermediate setup, okay, and before feeding this voltage or this power to the AC motor, we can have that control of the DC voltage. Okay, and then we can also have the control of the frequency, that is if that requires a certain adjustment. Okay, These converters are often called, just like we used to call the DC-DC converters, switched mode converters, okay, or switched mode DC to AC inverters. So again, this is just as was the case with the DC-DC converter, since there are intermediate components involved which perform the switching operation. So that is why we do have this name for it. The chapter title, this is in fact chapter number 8, okay, from the same book that we have followed for the converters, okay, that is of Nag-Mohan. So the chapter title is also switch mode DC to AC inverters, in which we have DC voltage on the input side and sinusoidal AC voltage on the output side. Okay, now let us talk about the reverse power flow a little bit. The lecture that we just concluded about the AC-DC converters, in that I also added the discussion about the reverse power flow, because this will also take place over here in the case of inverters as well. Okay, that although that most of the time the power flow is from the DC side to the AC side, okay, in the case of inverter, but quite often it is possible that the power flow does take place from the AC to the DC side. That is what we mean the reverse power flow. So how does this reverse power flow could be possible? Because last time when we discussed this reverse power flow in the case of AC-DC circuits, so in that case we mentioned that on the DC side we may have a potential source of energy in the form of a battery, or some power available in the form of DC voltage from a PV system. But how is it possible when in the case of inverter we, for example, have an AC motor as a load? Okay, so that is possible that when, for example, if the motor is slowed down, this is the load, the AC motor connected to the output of the inverter, if this is slowed down, so what happens that the kinetic energy associated with the inertia of the motor, okay, is recovered, okay, and during that brief interval, this is sort of called that when braking operation takes place, means when brakes are applied to this motor, or it has been slowed down. So this is that period that when kinetic energy associated with this motor, okay, due to the inertia is recovered, and during that brief interval this motor sort of acts to start as a generator, okay, that it starts to provide that energy, okay, and this is that interval that when the power starts to flow from the AC side to the DC side of this converter, and this is that interval in which now this inverter starts to operate as a rectifier, because now the power flow is from the AC to the DC side, okay. One possibility is that this brief interval in which this braking or slowing down of the motor takes place, and the motor sort of acts to starts to act as a generator instead of a motor or load, okay, we can dissipate that energy over here, in which we can have a resistor in parallel to this capacitor that we have over here. So we can have another parallel component in the form of resistor over here, at that excess energy can be dissipated across this component, okay. But this is the case if you just want to, you can say, sort of I would not say waste that energy, but since we don't have any other way of recovering this energy or using this energy, so that is what we have to do to somehow like accommodate this brief flow of reverse power. But let us imagine that this scenario happens quite frequently, like the motor achieves a certain speed, okay, it attains some momentum, and then it has that inertia associated with that momentum as well, and then due to whatever reason, for a brief interval, quite frequently, okay, this braking or this slowing down takes place, okay, and for after every like brief interval, okay, this reverse power flow starts to take place, okay. So then a better alternative which could come to mind is that how about that we can you can say either store this energy over here for that brief period, or even if this keeps on happening quite frequently, So we can make an arrangement for the reverse power flow, and that power could be provided to this utility grid. Okay. And the main requirement in this case is the only thing, the only thing in this case which is the main requirement, that we are having a two-quadrant converter. Now, if you remember, we had this discussion earlier in the case of rectifiers as well, and that converter should allow the reverse DC current to flow. Okay, that particular converter should operate as a rectifier. Okay, when this particular system is or this load is acting as a motor. Okay, and then when this starts to work as a generator or during the braking mode, that is working an inverter. Okay, so we need to have a setup like that for this particular case. Okay. In the block diagram that you would see in the book as well, that this one is quite often termed as a rectifier. The reason for that is that since for most of the time this would like take input from the AC side and provide the DC on the output side. So since primarily it is working on the conversion of power from AC to DC, so that is why it is normally labeled or termed as a rectifier. But just as I mentioned that in case we do want to provide that excess power during the braking mode or during the mode in which the AC motor is working as a generator, okay, to the grid, so in that brief interval it should work as an inverter as well. Okay, now there are generally two types of inverters. Okay, one of them is labeled as a voltage source inverter, or it has that abbreviation of VSI, and then we can also have a current source inverter, that is called as CSI. Okay, the case in which we can have the DC voltage source as an input to the inverter, so that is referred to as a voltage source inverter. So in this particular case, what we have a stiff DC voltage source, stiff or constant, as an input to the inverter. Well, this is the case in which for some of the applications, okay, specifically high power AC motor drives, we do consider that the input to the inverter is a DC current source. So such type of inverters are termed as current source inverters. Okay. Quite often the voltage source inverters are practically more easily realizable and find a lot of applications. Okay, only for some specific high power AC motor drive applications we use current source inverters, since most frequently voltage source inverters are used. So these are the ones that we'll investigate and discuss in a bit of detail. Okay, now further, the voltage source inverters can be divided into three general categories. Okay, the general categorization for this voltage source inverters is as follows. The first category, you may have heard the name as well, or termed as the PWM, or to be exact, pulse width modulation converters. Okay, another type of these type of inverters is called square wave inverter. While the third case of is relatively not commonly known. Okay, it is called single phase inverters. Okay, so let us discuss that what are the differences in each of these converters. In the first case, in which we are having the pulse width modulated inverters, or simply PWM inverters, for all of these cases, as I have already mentioned, that since these are different types of voltage source inverters in which the DC voltage acts as a source on the input side, okay, so in the first category of converters, the input DC voltage is considered to be constant, okay. So in this particular case, in the first case, we are considering the DC voltage to be constant. So now the inverter that is in operation, that should be able to control the magnitude as well as the frequency of the AC output voltage. So the inverter has to do this job of controlling the magnitude and frequency of output AC voltage. So how this is achieved? Actually, this is achieved by the pulse width modulation of the inverter switches, and that is the reason why it is called PWM inverters. How the pulse width modulation works, how does this name appear, this terminology of pulse width modulation. In the next lecture, we'll see the discussion of pulse width modulation of the switches, that how we can use this particular technique to control the magnitude as well as the frequency of the output AC voltages. Okay, then within the pulse width modulation, there are different schemes available which can shape the AC output voltage. As I mentioned in the beginning, that we can have sinusoidal voltages at the output. Okay, we can also have square voltages at the output. Okay, normally in most of the applications it is required that the output AC voltage should be of sinusoidal type. Okay, so one of the common PWM schemes, that is called SPWM. That means that we will try to achieve sinusoidal voltage through pulse width modulation at the output. Okay, and this is the one which is like used quite often in most of the applications. Okay, and that will be discussed in detail in our discussion of the inverters. Okay, this is about the first case. In the second case that we discussed, that we can have square wave inverters. So let us see that what is about that. Okay, in the case of square wave inverters, unlike the previous case in which the DC voltage was constant, okay, in this particular case the DC voltage is controlled, and now the inverter has to control the frequency only. Okay, and the output in this particular case is of square wave type. And that is why these inverters get this name of square wave inverters. Okay, so these are the two most common type of inverters, and of course within them, as I mentioned, that the PWM type of inverters are more popular because they find a lot of applications, because in this particular case we are able to get sinusoidal voltage signal or sinusoidal shape of the output AC, which are like used quite frequently in a lot of applications. Okay, the key differences in these two cases are that in this particular case the input voltage that it receives is constant, and now the inverter has to perform the controlling function for the magnitude as well as the frequency of the inverter. Okay, within the PWM there are different types of pulse width modulation techniques, and each technique basically gets its name from the way it shapes the output AC voltage. For example, if the output AC voltage is shaped to be of AC type, okay, of sinusoidal type, sorry, so that particular PWM technique gets its name a sinusoidal PWM, or sinusoidal pulse width modulation technique. In the next case, in the case of square wave inverters, this category the DC voltage is already controlled, okay, means the inverter gets a voltage which is of the value that is desired by the output, okay. So the inverter has only to do the controlling of the frequency, okay, and because there is no pulse width modulation applied in these type of converters, so what do we have? We have a square wave at the output of the inverter. With the third category, which is being given this name of single phase inverters with voltage cancellation. Now in this particular case, when we have the single phase output, this name or this term has been added because this particular application or this particular type of category is only possible with the single phase inverters, and this is not possible with the case of three phase inverters, okay. So although that with PWM type of inverters, when the input DC voltage is constant, so the inverter has to control the magnitude and frequency, and that is done with the help of pulse width modulation, okay. In the case of single phase inverters with voltage cancellation, even if the input voltage is of constant magnitude, that is we have a DC voltage on the input side which is constant, okay, it is still possible to control the magnitude and the frequency of the inverter output voltage. So whatever we discussed here for this particular case, that same is applicable for this particular category, despite the fact that we do not have any pulse width modulation, okay. And since we do not have any pulse width modulation, and as I mentioned that this particular technique is used to shape the output voltage according to a particular form of type, okay. So there is no pulse width modulation, so the output is of square type. So sort of these converters basically combine the characteristics of the previous two categories. That is, the input is of the first category, okay, that we have a constant DC voltage on the input side, and then just as was the case with this particular case, that it can control the magnitude and frequency of the output AC voltage, okay. But since there is no pulse width modulation in this third category, so the output voltage is of square type, which we had in the second category in the square inverter. So these sort of like combine the characteristics of the previous two inverters. But again, as I mentioned, that the first two categories are possible with either single or three phase inverters, while this third category is only possible with the case of three phase inverters. So this was some basic introduction and some general categorization about the inverters, the DC to AC converters, okay, their brief types and their categorization. In the next lecture, we'll further investigate the basic circuit concepts of inverters.